Hello everyone. Today let's solve the problem number 33, search in a rotated sorted array. So let's see what the question states here. We have been given an array nums. So you can clearly see here we are given an array nums, right? So here basically the nums array is sorted in the ascending order, right? So just keep this in mind. It is sorted in the ascending order. You can clearly see here, but it may have been rotated at unknown pivot. It may have been rotated at unknown pivot. So just give me a second here. So let me come here just 1 second. So yeah, here we have 456. This was initially 4567 was initially at this one. So it was 0 1 2 3 4 5 6 7, right? 4 5 6 7. This is rotated four times basically. This is rotated four times, right? So this becomes now 4 5 6 7 0 1 2, right? This becomes 4 5 6 7 0 1 2. So this is rotated sorted array. Rotated sorted array basically for this particular example it is rotated four times here, right? 4 5 6 7 comes first. So as it is sorted, it is 0 1 2 4 5 6 7, right? So it was initially, after rotating four times it has become 4 5 6 7 0 1 2, right? So we have been given target 0 as well. We have been given integer target. So what we need to find here, then we have to find the index of the given target using big of logarithmic n time. We have to find this element within the nums array, means this element within the nums array, and we have to return the index of it, not return the element. Here this is present at 0 1 2 3 4, fourth index, right? This is 0 index, so this one nums array is 0 indexed, and this is at the fourth, this one the index is 4, the index of 0 is 4, so we have to return its index. Basically we have to find the element 0 within the nums array and return its index, right? Here in this case we have got the output 4 because 0 is present in the index 4. Same goes with example 2 and 3. Suppose if we are not able to find the element, then we have to return -1. Suppose if we are not able to find the element within the nums array, then we have to return -1. Here you can clearly see we do not have the number 3. We do not have the number 3 within the nums array, so we have to return -1. So output is -1 here. Same goes with the example 3 as one. We have only one element, nothing but the number 1, right? The value 1 here. So the target that we have been given here is 0. So 0 is not present in the nums array. In this case we have to return -1. -1. I hope the question part is completely clear. Let's quickly discuss the approach, uh, followed by the complexities, and then let's write the code, and then let's write the code, right? So the first part here is, let's go with the first step here. We will be starting the binary search. So first thing is, before discussing the approach, I just want to tell you that we will be making use of the binary search, or we'll be going with the binary search approach. We'll be going with the binary search approach. Just keep this in mind. We'll be going with the binary search approach, right? So we'll be going with the binary search approach. So the first step here would be, we will start the binary search. We'll be going with the two pointers, one is low and one is high, pure binary search here, right? Binary search for the first example. So low will point to the first index, and the high will point to the this one last index here in this case, right? So index, this is 0, zeroth index. This is the final index, nothing but the 6. So low will be, the value will be 0. We are going with the index, not the value present at the array. So here in this case, this is 0th index and this is the 6th index. So here low we are initializing to 0 and high we are initializing to 6. So we have to find the mid initially. We have to find the mid. We are going with the range 0, 6, right? So this will be 0 plus 6 by 2, nothing but mid will be 3. 0 plus 6 by 2, nothing but 6 by 2, nothing but 3 here. Mid is 3. So we'll go with the nums of 3, nothing but 7. Mid we have found as 7 here, right? Mid we have found as 7 here. Let me delete this one. So mid we have found here as 7. Nums of 3, nothing but the 7. So here, target we have been given 0, right? Target we have been given 0. So we will check for the left part, nothing but nums of 0 we have 4, to nums of 3 we have 7, right? So this is sorted basically. This is sorted. This is sorted, right? So 4 to 7 is sorted. I'm speaking of only this one left part. We are not discussing the right part, this one yet, right? So we are discussing only the left part, and this part is sorted. 4 to 7, 4 5 6 7, right? So we will check is target 0 in the left part, so 0 is not present. 4 it is starting from the 4 and the whole array is sorted here, so 0 is not present quite obviously. So 0 is not present. Then what we will do now, low is 4 and high is 6, so right part we'll consider. Now we will consider the right part, so this becomes low. When we consider right part, we are left with 0 1 2, right? 0 1 2, right? So this becomes low. Sorry, low becomes, you know, for, yeah, sorry, this one I got confused here. This one, this becomes low and this becomes high. This becomes low and this becomes high. In this case, in the index, this will be fourth index and this will be sixth index. So when we calculate the mid, it becomes 4 plus 6 by 2, nothing but 10 by 2 is nothing but 5. So we will go with the nums of 5 here. We got 5, so we will go with the nums of 5. The value of nums of 5 is 1. The value of nums of 5 is 1. So this one, right part is also sorted. We know that right part is also sorted. We have 0 1 2 within the right part, right? This is sorted as well. So right part is sorted, so we will check is target 0 within the 0 1 2. Yes, it is. So what we'll do, we'll go left. We will go left. We'll go left. So now we have low 4, high also 4. So this one, right part is sorted, right? We will check whether the target 0 is present. So as it is sorted, so we have the target 0 and the value that we got here is 1. So we will move the right pointer to left, right? We will move the right pointer to left from 1 to 0, from 1 to 0, this one, 1 to the value 0, or from the fifth index to the fourth index, right? Yeah, from the fifth index to the fourth index, from the fifth index to the fourth index, nothing but the from value 1 to from value 0. Yes, we will check whether the 0 is present in 0 1 2. Yes, 0 is present in 0 1 2. So we will go left here. We will go left here. So low is 4 and high is also 4. Low is 4, high is also 4, mid is also 4. Mid is also 4. Why? Because 4 plus 4 8, so when we calculate the mid, it will be low plus high by 2. This will be 8 by 2, nothing but 4. So now the mid is also 4. Now the mid is also 4. So now whether we check nums of mid is the target value or not, nums of mid contains the target value or not. So nums of 4 is nothing but here, let me delete this entire thing. So nums of 4 here, see, 0 1 2 3 4, fourth value is nothing but the 0 here. This will be nums of mid, right? Nums of mid. So this will mid, I'll consider this one value 0. This is equal to target or not? Yeah, target we have been given 0. 0 equal to 0. Yes, 0 is equal to 0 here. So we have found successfully found the target here. So we have successfully found the target value here within the nums array. So what we will do, we will return 4. We will return the index of it, nothing but 4 here, right? We will return the index of it, nothing but 4. So we will go with the nums of 4, right? So this one 4 we will return as output. So 4 will return as output because we have found the 4 in the mid now, right? By performing the binary search basically, right? I hope this part is completely clear. We went step by step, right? So this is the approach that we'll be going with, pure binary search, right? Pure binary search. So this was asked in one of the interviews basically for me. This is important, just go through this one, right? So this is the approach that we'll be going with, right? This is the approach that we'll be going with. So we are done with the approach part. Let's quickly discuss the complexities. So what would be the time complexity here? The time complexity would be big of logarithmic, and as we are making use of the binary search, we are reducing this one search to search into halves every time. We are reducing the array or the search space into half every time, right? So here in this case, we are dividing the search space in half each time. So and we are making use of the binary search. Right, so because binary search divides the search space in half every time, the overall time complexity would be big of logarithmic n. So what would be the space complexity here? Space complexity would be big of 1. So the space complexity would be big of 1. So why is the space complexity big of 1 here? Because um, we will be making use of only few pointers. In our case, we'll be making use of low, high, and mid, right? Only 3 pointers here, 2 pointers along with the mid, right? So we'll be making use of only few pointers here in this case. So no extra memory will be used. So the space complexity would be quite obviously big of 1 here in this case. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of logarithmic n and big of 1. So as we are completely familiar with the approach and the complexities, let's start writing the code. Let's start writing the code. So first part here would be, let's go with the initial search boundaries. Means here in this case, int, so int low equals 0 and high, let's initialize this one to the last index, nothing but nums of length minus 1. Let's go step by step. Let's articulate the same thing that we have discussed in the approach in the form of code here, right? So here after this, let's perform the pure binary search, nothing but, so let's go with while low less than or equal to high, while low less than or equal to high, right? So first thing is we have to calculate the mid. Basically it prevents the overflow, right? So let's make use of the high minus low by 2. It prevents the overflow here. So instead of going with the low plus high by 2, I'll just go with here in this case low plus high minus low by 2, which basically prevents the overflow compared to low plus high by 2. That is the reason I'm using high minus low by 2. This is fine. So let's move on with the further step here. If the target is found at mid, then we have to return the mid. This is one of the edge cases, so I'll just go with nums of mid, this is equal to target, then we have to return mid. This is fine. So the next step is, let's go with the simple if condition. When nums of low is less than or equal to nums of mid, when nums of low is less than or equal to nums of mid, so I can just write here nums of low less than or equal to nums of mid, then what we need to do here, left half is quite obviously sorted. Left half is quite obviously started. Let's sorted. So let's go with the simple if condition here. This would be nums of low less than or equal to target, and target less than nums of mid. Target less than nums of mid. Then what we will do, we will assign high to mid minus 1. We'll assign high to mid minus 1. Else what we will do, low equals mid plus 1. Nothing but we are moving the left pointer to right. Right here, this one low equals mid plus 1, right? If the nums of low is less than or equal to target and target is less than nums of mid, we saw this one in the approach already, right? So we have to move the right pointer to left, nothing but high equals mid minus 1. Else if the target is in the right half, then we have to move the left pointer to one step right. So nothing but the low equals mid plus 1, low equals mid plus 1. We have one more condition here, we have one more condition, else so if the right half is sorted, now if the right half is sorted, right? So let's write the simple if condition here. This will be if nums of mid is less than target, if the nums of mid is less than target and target is less than or equal to nums of high, target is less than or equal to nums of high, then what we'll do, we will go with the target which is in the right half. Target will be in the quite obviously in the right half. So as the target will be in the right this one right half, we have to move the left pointer to right. Right here in this case, we have to give low equals mid plus 1, low equals mid plus 1. So else target will be in the left half and we have to move the right pointer to left, nothing but here in this case high equals mid minus 1, high equals mid minus 1. So we are done with the code. We are left with last step. We are left with last step. If the target is not found at all, we have to return minus 1. If the target is not found at all, we have to return minus 1. So this is it for the code. This is it for the code. Whatever we discussed in the approach, exact same thing we have articulated in the form of code. Exact same thing we have articulated in the form of code, right? I hope the coding part is completely clear. Let me do one thing. Let me hit the run button. I hope this works, man. Let's see. So you can clearly see here the sample test cases are getting passed, right? So let me hit the submit button. I hope this works for all the test cases. Let's see. So you can clearly see here all the test cases are getting passed, means the code works absolutely correct, right? The code works absolutely correct in this case. Let's do one thing very quickly. Yeah, let's do one thing. Or let's leave. Nothing. Here we are done with the coding part, right? So I hope the solution part is completely clear along with the complexities and the approach. For now, this is it. Thanks for watching, guys.